Hey, Than, that's cool. You came up with three ways to do this, so I'm going to do all three. So your first one was multiplying, I think, the numerator and the denominator by whatever we need to get to an LCD. So let me show that. So this side we would do d over d, and then this side we would do d plus b over d plus b. Do that. So that up here will get me d, p, and then d plus b. Why did they have to use d's and b's? It's confusing. And then g times this stuff, d plus b. And then here we would have the same d plus b. So once I get to here, I have this over this denominator equals this over this denominator. And so assuming that whatever would make the denominator 0, I would have to exclude if I were being really proper about this, but we're not. I'm going to cancel those out because, if I have x over 5 equals 9 over 5, you pretty much know that the x is going to be 9. So that's what I'm going to do here is just set these equal now. So then we have dp would equal gd. That really doesn't look like a... Try a little better. dp equals gd and then gb. And what am I solving for? I'm solving for d. Okay, so I have d's in two places. So I'm going to bring the d's over to one side. So I'm going to bring this one over here. And I have dp minus gd equals gb. And now I can factor that d out front, leaving p minus g equals gb, and then divide that over p minus g. Okay, so that's one way. That would work. The next way was clearing the denominators by multiplying both sides by the LCD. So let me show that right here. And once I get to the spot where you recognize it, I'll stop doing it. But I just want to show you that they all lead to the same place. So we'll do here, I'm just going to write LCD right there because I ran myself out of room. And then right here, I'll write it out so you can see what it is. So multiplying both sides by the d and the d plus b. So d plus b. And then remember, that's where that will clear these denominators. So if this is d plus b, I would have a dp right here. And then here, these would cancel, so I would have g, I'll go ahead and distribute gd, and then gb. And I should be right there, gb and dp. Yep, so now I'm right here. So that's why I like this better than all that, because it's a little bit less, which is nice. So it saved me a little bit of writing. So then the cross multiply thing, let's see what happens. So if I cross multiply, then I would have pd equals g times d plus b. And you can see right there, there's the gd and the gb. So what this is doing is, since I have a fraction equals a fraction, when I multiply this side, I totally should have written that out. Here it is. When I multiply this side, this denominator is going to cancel. So whatever this is going to cancel, and I'll just be left with that. Over here, when I multiplied this side by the LCD, this was going to cancel, which means I'm going to be left with this times this. So that's why that works. It only works when you have a single fraction equals a single fraction. It is the same thing as doing this. It's just a little more efficient because you're not showing that canceling step right there. You're just kind of skipping that and writing it out. So all three lead to the same spot and the same answer. I always take the shortest path when I can. Hopefully that helped.